Welcome to part 3. It's a hard one, but you can do it.
Hello students, in this part of our lesson 4 we are going to look at the second skill that you need to acquire from the Pythagorean theorem, and that is to use the Pythagorean theorem to calculate a missing measurement. Here are the steps to doing that. Label the legs A and B. Label the hypotenuse, the longest side, C. Second, substitute your known values for A, B, and or C. You will not know all the values. You will know 2 out of the 3 and will be using the Pythagorean theorem to figure out that third one. So you will only be able to substitute 2 of these 3 amounts. So step 3 is to leave the variable for your missing measurement. Leave the A or the B or the C for whichever one you don't know. Fourth, solve the equation by using inverse operations. Steps for this part will vary depending on whether you're finding the smallest, medium, or longest side of the triangle, and I will show you one of each type of example so that you have clearly in your notes exactly how to solve each type. What I want you to make sure that you do is write down every step the way I show you, because that is the way I expect you to solve the equation. So let's start with the easiest of the 3 lengths to find, and that is to find the hypotenuse, the longest side. So you can see if you look at the right angle that we are looking at the longest side of the triangle being the missing one. If you draw an arrow towards the corner of your right angle symbol, you will see that it's pointing to the C, the longest side. So our first step is to label A, B, and C. C is already labeled, so we know this is our A because it's the shortest side, this is our B because it's the medium side, and this is our C because it's the longest, or the one formed by the right angle. Our second step is to write down A squared plus B squared equals C squared, and to substitute the values that we know. We know that A is 7, so we'll write 7 squared, plus we know that B is 8, so we put 8 squared, and we know that that equals C squared. 7 squared is the same as 7 times 7, which is 49, plus 8 squared is 8 times 8, which is 64, and we're going to have to let it say C squared since we don't know that value. That's what we're looking for. Our next step is going to be to add these two amounts together. 49 plus 64. 9 plus 4 is 13. 1, 4, and 6 make 11. So we get 113 is equal to C squared. But we don't want to know what C as a square would be. We just want to know the length of C. So we need to eliminate the square. The opposite of a square is a square root. So if we square root a square, it will eliminate the two operations because they are opposites of each other. But what we do to one side, if we square this side, we're going to have to do to the other side. So we get the square root of 113. If you look at what's left, we have the square root of 113 is equal to C. This length is equal to the square root of 113. Now we know that 113 is not a perfect square root, that it lies between the square root of 100, which is 10, and the square root of 121, which is 11. So we know that this is 10 and a fraction. The difference between 100 and 113 is 13 digits. The difference between 100 and 121 is 21 digits. For sake of time, I'm going to use the calculator to divide 13 into 21. 13 by 21, sorry, and I get 0.61. So I know that this is about 10.6. So this missing length of the triangle is equal to 10.6. This is the only length that this side of the triangle could be in order for this triangle to have that right angle. Now let's try an example of finding the shortest side of the triangle. Our first step is to label A, B, and C. A is labeled, 12 is our medium side, 13 is our longest side. Write down our Pythagorean theorem, a squared plus b squared equals c squared. Nothing's different so far. Now, when we try to substitute, we do not know the value of a, so we're going to leave that variable there. We do know that b is 12, so we have 12 squared, and we know that that equals c squared, or 13 squared. Now, we can simplify our squares of our constants. We know that 12 squared is 144, so we have a squared plus 144 equals 13 squared. Well, we know that 13 times 13 is 169, and if you didn't know that, you could do it on the side of your paper. Now, our goal is to get a all alone, to figure out what a's value is. But we have a square with it, and we have plus 144. To get rid of plus 144, we're going to have to subtract 144. But what we do to one side, we have to do to the other. So we're going to subtract 144 from this side as well. 144 minus 144 is 0, so we have just a squared left on the left side of our equation. On the right side, we have 169 minus 144, which is 25. We know that the opposite of squaring is to square root, so we need to square root each side so that the square and the square root eliminate each other. But what we do to one side, we have to do to the other, so now we have the square root of 25. If you look at what we have left, we have a equals the square root of 25, which is a perfect square root. So a is equal to 5. 5 is the only length that this side could be to have a perfect right angle. Now let's find the length of the medium side. Notice the medium side is going to be the letter B. So we have A is 15, B is unknown, C is 25. So if we write our Pythagorean theorem, a squared plus b squared equals c squared, we can start to substitute the values that we know. We know that 15 is a, so we have 15 squared, plus b squared, we're going to have to put b because that's our unknown amount, and it's equal to c, which is 25 squared. 15 squared is equal to 225. So we have 225 plus b squared equals, and 25 squared is 625. Let me just double check that. I'm pretty sure. Yep. 25 times 25 is 625. Now, our goal is to isolate b, to figure out what just the b is. But you can see that it says 225 with it on that left side of the equation. So we need to subtract 225 so that we can cross out the 225, since 225 minus 225 makes 0. But what we do to one side, we have to do to the other. So we're going to have to take away 225 from this side as well. That leaves us with b squared equals 400. Now, to get rid of the square, we're going to have to square root each side. Since the square and the square root are opposite operations, they will eliminate, but what we do to one side, we'll have to do to the other. So we'll have to square root this side as well. So we get b equals the square root of 400. The square root of 400 is equal to 20. 20 times 20 is equal to 400. So we now know that the only length that this side of the right triangle could be is 20. Now let's look at how we could use this on a coordinate plane. Let's find the length of the hypotenuse in a triangle if the coordinates are negative 5, 0, so you learn that that's right here, negative 5, 6, which will be here, and 0, 6, which will be here. If we connect them, we can see that they are a right triangle because this side is horizontal, this side is vertical, and you can even see right here in the corner, there's a right angle. Now our goal is to figure out the hypotenuse. How far is it from here at -5, 0 to here at 0, 6? Well, we can use the blocks on the coordinate plane to help us. How long is the shortest side of the triangle? If you count blocks, 1, 2, 3, 4, 5. And if you count the height, 1, 2, 3, 4, 5, 6 would be the height. So our A is 5, our B is 6, and our C is our unknown. And you could imagine how we would go through the steps following that first example. But I just wanted to show you how to lay out, plot those points, draw, and label the lengths of the sides of a triangle on a coordinate plane. Now, let's try an application question. This question has 2 steps, and you will see some just like this on your PSSA this year. It says, use the Pythagorean theorem to find the height of the triangle and then find the area of a triangle. Remember, area of a triangle is always equal to 1/2 times the base times the height. So you can see that since the height is an unknown here, we are going to have to figure out what that height is first because it's part of what I need for this problem, for figuring out the area. Well, if you zone in just on this half of the triangle, do you see how you see a right triangle and you have 2 of the dimensions and you can figure out the other one? So let's use a squared plus b squared equals c squared to figure out this height, which happens to be the A, the shortest side of the triangle. So we have a squared, which we don't know the a squared, plus b squared, we know that the medium side is 5, so we have 5 squared, equals the longest side, which is 7 squared. So we have a squared plus 25 equals 49. If we subtract 25 from each side, we get a squared equals 24. If we square root each side, the square and the square root will cancel, and we get a equals the square root of 24, which we know is not a perfect square root. We know that it's between the square root of 16, which is 4, and the square root of 25, which is 5. So this is going to be 4 point something. If we look at the differences, it is 8 different between 16 and 24, and 9 different between 16 and 25. If we divide 8 and 9, we get 0.88, which rounds to 0.9. So this is about 4.9. So the height of this triangle is 4.9 units. So now we know our A, because we use the Pythagorean theorem, we know that A is 4.9. We can now figure out the area by substituting values. The area equals 1/2 times the base, and if you look at the entire base, it's 3 and 5, which is 8, times the height, which is 4.9. Half of 8 is 4, so we have 4 times 4.9. 4 times 4.9 is 19.6. So the area is 19.6 square units, and we know it's square units because it's area. On this last slide, you see a summary of the Pythagorean theorem and all that we've learned in this lesson. This is a difficult concept and we'll practice it a lot in class. If you have questions, please ask. Have a good evening.